Good evening, everyone. I hope everybody's doing well tonight. In this lesson, it's going to be kind of an introduction into the concepts of multiplication and division. Before we get into using numbers and the algorithms to solve the problems, first thing we're going to do is discuss the concepts and the ideas behind it and some strategies that you can do at home and work with your kids. I'm not going to be using any numbers this evening. We're just going to look at some different examples of how to think about it. And division concepts. And of course, a concept is an idea or a way to think about something. Okay. The first thing I want to look at here is the idea with multiplication. All right. And that is going to be, there's two train of thoughts when it comes to multiplication. The first one is going to be equal groups. And the second one is repeated addition. Okay, and I'm going to show you some examples of how you can work at home with these type of ideas. The next thing we're going to take a look at is division. There's a few different ways to think about division. What I'm going to do is focus on equal sharing. Okay, so again, multiplication, we're going to be looking at equal groups and repeated addition. And with division, we're going to be looking at equal sharing. And I'll show you some strategies that you can work with your kids at home. All right. Okay, we're going to be working with manipulatives first. And in a classroom setting, a manipulative means a hands-on tool to learn with. Okay. And the style of learning is called tactile. That means to touch and learn. Some kids are excellent tactile learners. Some kids are well-rounded and they can do well with tactile learning, auditory learning, visual learning, those type of learning modalities. Tactile is about touching and learning. Okay, so let's take a look first at, we're going to take a look at some ways where we can make equal groups. I'm going to go ahead and get some batteries here. We have Energizer batteries. Okay, so you can see how many I have here. You can see that I have 8 of them total. Okay, and what I want to do is just try to think of different ways that I can group them equally. For this demonstration, I don't want to have any type of remainders at all. When we look at division concepts, of course, there's going to be remainders. But for elementary school and multiplication, we don't really work a whole lot with unequal groups. We do a little bit, and I'll give a little bit of a taste of that, but really not too much. So the first thing I see here is I have two equal groups of 4 if I go like that. So that would be a concept right there. I have 2 groups of 4, and I know that 2 groups of 4 equals 8 total because I have 8 batteries all together. There we go. Put them together. I wonder what other kind of ways I can make this. What if I had 4 equal groups of 2? Would I still have 8? Of course, because there's 8 total batteries here. So in this case, I have 4 equal groups of 2. 4 times 2 equals 8. I wonder what other kind of ways that I can actually put these into equal groups. When you're working at home with your kid, ask him questions like that. What other kind of equal groups can we make? Let's see. They might do stuff like this. And this is good experimentation. Okay, well I have 2 equal groups of 3. I have 1 group of 2. That doesn't make equal groups. What if I make 1 group of 4? I mean, rather 1 group of 8. Can I do that? Sure. That's an equal group. 1 group of 8. So what we're doing right now is we're finding all of the different ways where we can make equal groups. Now, equal groups and repeated addition are linked with the way in finding the correct answer. It's just a different way to think of it. Okay, so for this example, I'm going to break these into 4 equal groups of 2, like I had done earlier. Okay, so we're going to use this now. We're going to think about it differently, though. So we're going to say 2 plus 2 plus 2 plus 2 equals 8. You can also say 2 plus 2 equals 4, 4 plus 2 equals 6, 6 plus 2 equals 8. So that would be a way to do repeated addition. Two groups of 4 right here, 2 groups of 4. So 4 plus 4 equals 8. Pretty simple. Let's look at some other examples. And I do encourage you, one thing if you notice is that I'm using, a suggestion is to use the same type of something when you do this at home, okay? So practice with the same type. Especially for young children. This is a good idea. Okay, so I'm going to go ahead and put the dry erase board down. And I'm going to get out some beans. A bean soup mix that has been in my cupboard for about 2 years. I have no idea why I wouldn't want to actually, oh, there's a ham-flavored packet inside. I didn't realize that. Maybe that would have been eaten about 2 years ago had I seen that. Okay, so I'm just gonna take a little bit out. Okay, don't want to make a mess. A mess is fine, of course. Okay, I'm gonna put them in a bowl here. And remember what kind of learning this is. This is tactile learning with just manipulatives that you can have at home. In later videos, we'll get into the numbers, and you know, I'll show you different ways that you can work with your kids at home to be able to achieve what's called automaticity and just the memorization of numbers. Okay, so remember, I kind of want to look at the same type of something. So what I want to do is maybe get these kidney beans out. No, they're maybe these ones, these little pinto beans. I'm gonna get these out. There's more of them. And what we're going to do is we're going to experiment with the idea of equal groups. Your kid will have a blast with stuff like this, I guarantee it. They'll look through the entire bowl to find every single pinto bean. Another thing you can do with kids, and I'll talk about this a little bit more in the video, is what's called a scavenger hunt. And I've done this in the classroom with kids, with this teaching them this concept. You know, find things in the classroom that are alike, and then bring them to your table groups, and we'll go ahead and divide them into different, and we'll see how many ways we can make equal groups. They love that. This one's a half. Okay, kids will not like that, believe me, even though it's a pinto bean. And if you're more interested in why children think that way, read up on Jean Piaget and his theories of childhood development, especially for like a kid who's 8 and 9 years old. They're still in that what's called a concrete operational stage for the most part. An adult would be able just to separate all the different types of beans into equal groups, but younger kids have a little bit of a harder time with that. Some kids might even look at this and say, you know what, that's too smooth. That's not a pinto bean. All right, fine. Let's get the ones that are not pinto beans at all out of the way. You know how kids are. They're very particular about stuff like that. All right, so I think that's probably pretty good enough. Oh, that one is not going to work. We're going to get rid of that immediately. Okay, so let's go ahead and see how many we have, and let's see what kind of equal groups we can make. Let's work in groups of 5. We have one group of 5. We have 2 groups of 5. And when you work with kids and you're doing stuff like this with these manipulatives, try to separate them. Okay, some kids, when they're trying to separate, they get them too close. All right, and then the next thing you know, they lose track of how many they have, especially the younger kids. So you want to go ahead and put them into different groups like this. Okay, I have 3 right here. I'm not going to work with remainders right now. All right, but what I have here is I have 4 groups, 1, 2, 3, 4 groups of 5, 4 equal groups of 5 pinto beans. You can even do this is the beginning of the word problems too, where you pose different word problems for the kids. Like Stacy has 20 pinto beans all together. She wants to put them in 4 equal groups. How many pinto beans does she have in each group? Okay, that would be a typical question for a child who's in third grade, second, third grade, perhaps, you know. And this is a great way for them to learn. Okay, well, I see that there's 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I see that Stacy has 5 pinto beans in 4 equal groups. Okay, 4 equal groups of 5. Another thing that you can do is, at this point, just have them count, you know. Some kids, you know, if they're younger, they may not be able to skip count. So just have them go by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's totally fine. 4 groups of 5 equals 20. And what you're doing is you're building this concept of multiplication in their brains, right? 4 times 5 equals 20. And then, of course, we can work on that repeated addition. So 5 plus 5 is 5 plus 5 plus 5 plus 5 equals 20. Or 5 plus 5 is 10. 10 plus 5 is 15. 15 plus 5 equals 20. Okay. And what you're doing, actually, and we'll talk about this, is they're dividing as well. And we know that there is, of course, a relationship between multiplication and division, and this is helping them to, you know, when we put them in the center, we're actually dividing them into different types of groups. Have them explore this idea. Okay, so let's see what some other equal groups that I can make. Some kids might want to make a line. After a while, when you know, I've been working with kids for quite a while now, you know, you can just grab a handful of manipulatives and pretty much just guess, you know, I mean, you pretty much know how many are in each equal group just through a lot of practice. Let's see what this is like. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's not going to work. Okay. And that sort of disproved my notion right there. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now I have 2 equal groups of 10. 10 plus 10 equals 20. So again, it's reinforcing those concepts of, you know, equal groups and repeated addition. And those are going to be the main things when it comes to multiplication. Kids love this stuff. You know, it's hands-on. You know, it's really good for, you know, it's kind of a bonding experience, something when it comes to working with manipulatives. You know, as a teacher, sometimes, you know, I'll get into the numbers and we'll be working a lot on the algorithms and things like that, on how to solve the problems. And then, you know, I got to take a step back and say, you know what, let's have some fun. Let's go ahead and take a look at some manipulatives. Let's see how we can bundle equal groups. Okay, so those are beans, right? So the idea of bundling, once again, okay, get something of the same type. I see that I have some Ticonderogas here. Excellent pencil. Okay, now one of the things that you know, you can have your kids do is to make what's called equal bundles, and those are equal groups, right? So let's make, let's see how many equal bundles of 3 we can make. Okay, well, here's one equal bundle of 3. Take a little bit of tape if you want to. Oh, that's not an equal group. This is a simple one. Bundling, great idea. You can do this with, all kinds of different objects in your home. Paper clips, maybe rubber bands, screws perhaps, nails. As long as they're of a similar type, that's going to be the biggest thing that I'll emphasize with that. Even the way I'm demonstrating here with my 2 groups of 3 Ticonderogas, each one of them have not been used. There's no sharpened edge. The erasers have not been used. And there's a reason why I'm demonstrating this. It's because in a child's mind, they really want to see something that is similar and the same. To an adult, it really just doesn't matter. And older kids, it doesn't matter either. A pencil's a pencil. I can get one that's sharpened and it's still a pencil. No, that's true. Okay, but when a child is learning about equal groups for the first time, it's my opinion to use things that are that match as much as possible. All right. We have, right, 2 equal groups of 3. And we know that there's 6 total, so of course 2 times 3 equals 6. 3 plus 3 equals 6. So what I'm doing, of course, is reinforcing those ideas of equal groups and repeated addition. One of the things that I love to work with, with children in the classroom is arrays. And I'm going to show you how to work, how to use arrays at home with grid paper here in a second. But this is a pretty cool idea too. Notice once again that we're not using numbers at this point at all. And kids are really clever with this stuff too. They surprise me all the time. Here I have 4 equal groups of 2, 3, 4, 5, 6, 7. 4 equal groups of 7. You can ask your kid, well, how many do you think you actually have there altogether? Do you think it's less than 30? Do you think it's going to be more than 20? What about 50? Do you think it's 100? You ask questions like that to your kid, and you're going to get an idea of how they estimate. If a kid thinks it's 100, well, then obviously they're going to have to, work more on their sense of numbers and just the total amount of things for sure. Okay. So now what you can do is you can play around and just make some equal groups. Okay. I wonder how many equal groups of 6 I can make with this. Have them designed different ways, whatever. 2, 3, 4, 5, 6. Okay, so I have one equal group of 6. Look how fun this is. I'm having fun actually. 1, 2, 3, 4. Eventually you want to try to break them from the idea that their equal groups have to look the same. You want to introduce it's okay if there's a different color. But when you're first working with kids, you don't really, you don't really want to do that. 1, 2, 3, 4, 5, 6. Some kids, when you're doing this, they just, look at the pattern. Look at the pattern. They're not even thinking about the numbers and what you're doing. They're just like mesmerized. Oh, wow, look at that. So anyhow, okay, so it looks to me like I have 4 groups of 6 equally here. And I wonder what 4 equal groups of 6 is. I wonder if it is more than 40. I wonder if it is less than 10. And you ask them those questions before they actually count. Okay, at this point you want to obviously get away from the mystery. See how your child is actually counting these. Are they going by ones? Can they skip count? Which is, 6, 12, 18, 24. Can they do that? I guarantee a lot of my students can. Guarantee. And then, of course, you have that idea of, repeated addition. 6 plus 6 is 12. 12 plus 6 is 18. 18 plus 6 equals 24. They start to see patterns. Oh, wow. Every time I add a 6, I'm actually adding to another even number. It's totally fine if a kid does this too. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And that's going to give you information about how well your child understands these ideas. Okay, if they get a little bit confused by this, by all means, circle it. Oh, now I see that they're equal groups. And now I see that there's 4 of them. And now I see that there's 6 in each equal group. I guarantee kids are going to respond to stuff like that when you show them. I guarantee. Okay, let me get some more paper. Show you some more examples. Alrighty. Okay, the next thing I want to show you are arrays. Okay, if you go to any store basically in town and you get grid paper, a lot of the grid paper is going to be very small like this. Say if I go to, the typical stores like Walmart or Office Depot. In fact, I got this at Office Depot. The squares are going to be smaller. This is fine for kids that are a little bit more advanced, but for children that are just learning the idea of arrays, I would keep it simple and try to print off something where the squares are a little bit bigger. Okay, I went and just did a quick little search on the internet, grid paper, and I found this. Okay. All right, so one thing that you want to do with this is start to cut different arrays. And what I'm going to focus on is the idea of a square product. Okay. A square product is one factor multiplied by the same factor. So So for example, 1 times 1. This is the most simple array that you could have. And that is an array. This is a 1 by 1 or a 1 times 1 array. And we know that 1 times 1, of course, equals 1. Okay. What happens if, instead of a 1 by 1 array, I do something that's a little bit bigger? Arrays are a great visual way for children to understand multiplication, and it's a really good foundation for them to understand area later. Okay. So I have probably the most basic multiplication problem right here. And now I have 2 equal groups of 2. In the next lesson, ways to multiply, we'll be actually writing the numbers in here so you can understand. And you folks already understand the idea of area and arrays, but it's just a refresher. And I guarantee my students do. Here's another array with equal groups. And really what you're building is, every time I add another side, or every time I add another row and another column, this is getting larger. And those are the concepts you want to build. This is an equal group concept. Take a look at this one. See, this is a 4 by 4 array. Ask your kid, do you know can you guess how many are in that 4 by 4 array? One thing that I like to do, and I'm kind of a nerd like this, is if I'm say I'm at a grocery store or something like that, and I'm in line, and just to kind of pass the time, I might look at a square tile, and then I'll focus on one, and then I'll look at one tile, and then I'll see a 2 by 2 tile, which is 4, of course, and then see how far off I can expand my field of vision to have these type of square products. Okay. All right, now we have a 5 by 5 array. And these are the rows. 1, 2, 3, 4, 5 rows. And we have 1, 2, 3, 4, 5 columns. And if we were to actually count them all, we would have 25, because we know that 5 times 5 equals 25. You can do the repeated addition here if you want to. 5, 10, 15, 20, 25. And I guarantee all kids know how to skip count by 5s by 3rd grade. All of them do, because the younger grades really drill them when it comes to skip counting certain numbers. And that's an idea of repeated addition. Tomorrow, when well, for the next lesson, I don't know about tomorrow, but when we look at the multiplication facts, the basic multiplication facts, we'll think of this as 5 times 5 equals 25. Then they get that idea that, when I'm starting to multiply higher numbers, I'm getting a bigger area. And that is so key to helping your child understand geometry and area and perimeter and just their spatial reasoning. Okay, now these are called square products. And the reason they're called a square product is because it makes a square shape. When two of the same factors are multiplied together, it makes a square shape. Okay, so you don't have to just work with square products. This is just an example. This is another cool thing to do too. Is to show them. It's almost like a pyramid. Forgot about this. You can even get into three-dimensional models. These are just 2 dimensions, of course, but you can get into three-dimensional models with the sides. Build like a little pyramid for them. It's pretty cool. Okay, so those are going to be special ones, obviously, but those aren't the only ones where we have equal groups. So I'm going to use this here. Just some other examples. My mentor teacher, the teacher that kind of showed me how to teach when I was in graduate school, Mr. McDougall, I'll give him a shout out. I'll never forget, he said, I didn't understand multiplication when I was a kid until I learned about arrays. And I thought that was a profound thing that he told me, and I never forgot that. He became Teacher of the Year. He was a phenomenal teacher. Very lucky to have learned from him. Okay, so now arrays. It doesn't have to be a same square. Okay, here's a 3x4 where I have 3 rows, 1, 2, 3, and I have 1, 2, 3, 4 in each row. And I get a total of 12 if I were to count that. I can do the repeated addition, 4, 8, 12. I love skip counting, and I'll show some examples and some strategies you can use with your child to skip count. We would do it in the classroom just as a way to drill. Now, if you notice, this is going to be a 3x4. We no longer have the square shape anymore because it's not a square product. Even if you look at that word array, it looks like area. And we can go on and on about arrays. Let me just show you another example, just so, just one more example of arrays, because when I do my demonstrations of ways to multiply, we'll go into more details about arrays, and then later on when I do demonstrations of area and perimeter, we're going to be looking at arrays again. So this is just an introduction basically. Okay, so here's another type of array. We have two equal groups of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I know that two equal groups of 10 is 20. So equal groups, 2 of 10, repeated addition, 10 plus 10 equals 20. And those are going to be basically your multiplication concepts. Can I get away with this? Nope. All right, so division, and we're going to do what's called equal sharing. So I'm gonna show some examples, and we can do is introduce remainder as well, because a remainder is more common than having equal groups with division. But at first, when a child is just experimenting with the idea of division, remainders are not introduced at first. My students already have experimented with remainders, and they understand it just fine. Okay, so what we're gonna do is we're gonna put the total here. This is called a sharing mat. In my classroom, and of course, schools are closed right now, but we have what are called sharing mats, and they're things that the kids can use to be able to divide into equal parts. And they have these little things like this. So this would be a sharing mat where I could equally divide something into, say, 4 equal parts. Kids love this. And if you have it on a dry erase board, oh, they'll go nuts with it, I guarantee it. So, we have the total amount, just total amount, whatever. And then we have our equal parts. Okay. This sharing mat, you would only be able to share into 4 equal parts with this one. So let's grab, get back to the pinto beans. Probably shouldn't have put them back in the bowl, but that's okay. They're on top. Okay. All right, we'll do something like this. Okay. Have your some suggestions are to put these, have your kids sort of organize these in ways where maybe there's equal rows or something like that. It doesn't really matter, but it is helpful. In this case, because of demonstration purposes, I don't want to have any remainders, so I'm going to make sure that I have them in equal groups beforehand for the demonstration. Okay, so now with with a sharing mat, one of the things that you want to do, especially when kids are just learning out, is have them divide equally into parts. Have them do it systematically. I've seen so many kids get confused because they want to go here, and then they want to put a bean here, and then they lose complete track of what they're doing. So, I teach my students to put them in, be systematic, go left to right, I even have them follow this line down so they can be put into the equal groups like this. Okay. Even for those younger kids, you know, especially for them. Okay. All right, now I had the total amount, which was actually 16. We probably should have counted that out first, actually. And now I see that I had 16. I put them equally into 4 groups, and I have 4 beans total in each group. This is equal sharing. Okay. All right, I'm gonna move my pinto beans aside, and I'm gonna get this out. A dry erase board is gonna obviously be more advantageous to what I'm doing here because all I have to do is just erase it and make more. Kids get real creative with their sharing mats when they use a dry erase board. It doesn't really matter, you know, how it looks at this point, you know. Put one over here. As long as they're getting the idea, and as long as they're dividing it in a certain way here. And of course, I'm still, you know, I'm a grown boy, and you know how boys are for the most part, a little bit. For the most part, are a little bit, you know, messier the way it looks and things like that. Okay, haven't completely grown out of that. So, okay, so now, but however messy it may be, okay, what I want to do is I want to, you know, just get the idea. Say 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15, 16. Okay. And now I want to put them into 1, 2, 3, 4, 5, 6, 7, 8 equal groups. Okay. And I mean, you know, when I'm doing demonstrations like this, I have to tell, you know, I have to wave the kids' hands down sometimes because they just want to give me the answer, you know. Especially when they get it right away. But, you know, I'm a little bit insistent. I'm like, you know, don't tell me the answer. We're just going to get the idea, the concept. Okay. So now I'm going to start here, right? Maybe I'll even do like indicate a little star or something. And I'm going to go this way, and I'm going to go all the way around. Show that directionality for a kid. When you're doing a sharing mat. And you can even, you know, you can discuss other things. Okay, well, this is clockwise when we go around this way. So there's all kinds of different learning opportunities. Okay, so I'm going to start here where the star is, and I'm going to put 1 in each equal group. So I noticed that there were 16 beans in total, and I put them into 8 equal groups, and there are 2 beans in each equal group. And again, you know, you can pose different different number problems with sentences, number sentences, you know, and you know, there's 16 people, and there's 8 cars, and they're going to they're going to be riding separately. Okay, how many people per car can they ride in? How many people per car? And they'll think about it. And especially younger kids, they love stuff like that. Well, where are they going and what do they look like? Is it going to be are there all boys? Is there a mixture of boys and girls going together? So they want to know the situation and the scenario. And, when you pose things like that to them, oh, they just get it right away. And it's also a wonderful introduction to word problems. Those mathematical story problems that can become very tricky, and become more complicated over time, definitely. Okay, so now I see that there are 2 people in each car. There were 16 people total. And if you want to, and of course this was fabricated the way I did this, right? I knew that there was going to be 2 in each equal group because I had a 16 total, and I made how many how many parts that they would go into equally, of course. But with division, rarely do we ever have equal groups, right? And division is a beautiful thing. I mean, you see little kids trying to divide things amongst themselves, right? And they don't really know how to do that, and they start strategizing. You can see it in their little brains. One will bring some candy, and he's got 2 buddies, and he's trying to divide 6 Skittles equally, between a couple buddies. And if each kid doesn't get 2 Skittles, it could be a real problem. That can cause a bad day for everybody. All right, so total parts. Okay. So now, once again, I'm working with the same amount of beans at first, which is 16. Let me double check to make sure. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16. Okay, there's nothing worse, than using a sharing mat and not having the right total when you're first starting a problem with kids. And I've seen that numerous times because you're trying to show them correctness, ultimately how to do this correctly. And if you don't have the right total, then they're not going to have the right amount in each part. Okay, as many of you can tell, obviously, there's going to be some remainders in this, and that's fine. The first couple examples, obviously, I didn't show remainder like I said prior, but at this point, it is normal to have remainders, so we'll just show it. Now, remember, please, especially when kids are first learning, to have them be systematic with the way they divide. They will get confused to no end and have to start over again if they break the order of the division. Okay. At this point, you do have one remaining pinto bean here, and it's not going to be put into a equal group. That's your remainder right there. Okay, I had 16 pinto beans. I put them into 3 equal groups, and now I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I have 3 equal groups of 5, and I have 1 remaining pinto bean. And of course, pose a scenario, okay? There was 16 people, and, there was 3 SUVs. And, in the classroom, it's wonderful. It's a beautiful thing. They start asking you, well, what's the color of the SUV? Maybe I'll even pose the question. It gets everybody engaged right away for learning, and they get invested in the learning. And that is that is something that, once they become invested in learning and they become curious, then they want to know how it's the process. Then they're not playing in their desk anymore, spacing out or goofing off with their friends. There was 16 people and 3 cars, and how many people in each car equally could you put them into? Well, you can put them into three cars, and 5 people can be in each car. And then you have to have with children, which is just a delightful thing when you're a teacher, and something that I miss greatly because the schools are closed right now, is what about this person? They go wild. Well, they got kicked out of the car, because they weren't following the rules, or, they didn't like that person, and they start going off. And like I said, getting them invested is something that is invaluable with teaching. Okay, so that's an example there of equal sharing with division. All right, let's go ahead and take a look once again. Let's just do a quick review. Okay, of the lesson this evening. Okay, so multiplication, and division concepts. Okay, and of course concepts is the idea of something. All right, so with multiplication, two things: equal groups and repeated addition. With division, equal sharing. There's some other division concepts, but they're a little bit complicated, and I don't really want to go into it right now. But we'll probably run into some of the problems where it's obvious when we're working with the numbers. Okay, so tonight there was no working with numbers whatsoever. We want to get the concept, we want to get the idea. Okay, at home you can work with manipulatives. That glare is kind of bugging me. Let's see. Okay, here's an idea that you can do at home with your kid. Okay, and this is just a suggestion. Have them do a scavenger hunt to find the same type of things. Then challenge your kid to make equal groups. In various equal groups too. They'll love it. And you'll be very surprised too they'll organize your cupboards for you. They'll go in your cabinets, and they'll put things into equal types. Before you know it, you'll have your whole entire house organized. And I know this is true because I've done this in the classroom, and they go wild. Okay, I hope you enjoyed this video. Remember to experiment with manipulatives, and it's wonderful for the hands-on learning. And those kids that are very tactile learners, and they need to touch things and to experience those type of things. Remember that you can turn these concepts and what you're doing into real life scenarios and or different situations, and that'll help a child. And I did mention it earlier. With Jean Piaget is his name. He's a famous child theorist, a child developmental theorist, and he is just renowned throughout the world. Passed on a while back, of course, but his theories live on. And when you pose different scenarios to kids, it helps to get them out of that concrete way of thinking and help them move them into hypotheticals. And that is another development in the human cognition with their way of thinking and developing. So anyhow, scavenger hunts, great idea. Have them enjoy what they're doing. Try to make when you're doing these eco groups, try to make the same type of things, and enjoy your kid getting motivated to organize your home. Have a good evening.